My name is Steve Watt. I work for the CTO office at Red Hat, and this is one of our special sessions in our brand new CTO office track at Red Hat Summit. And this track is a little different in that most of the other tracks at Red Hat Summits are about products and product roadmaps. And what CTO office track is, we want to sort of pull back the curtain a little bit and let our customers and our partners, everyone attending Red Hat Summit, to sort of see a little bit about what we're dreaming about, right? And sort of see where we're innovating and the fact that we're not just fast followers, right? And so, as you can see, I have Brandon Phillips, CTO of CoreOS, recently acquired by Red Hat. And I have Clayton Coleman, who's the chief engineer for OpenShift. Many of you folks know, if you are around the Kubernetes community, that these are two of the most significant contributors in the Kubernetes ecosystem. And so, but just before we jump in, I just want to sort of give us an opportunity to calibrate with you so you get the most out of the session. So I just had a question. How many folks in this room would sort of categorize themselves as sysadmins? Okay. And how about software engineers? Okay, and how about enterprise architects? And other? Okay, and then one last one. How many of you would say you have an advanced familiarity, well, an advanced capability with Kubernetes? Okay, intermediate? Basic? Okay, all right, that's good. All right, so let's start off with Brandon. Can you tell us a little bit about yourself and your journey with Kubernetes and its ecosystem?
Sure.
And then we'll go on to Clayton.
Sure. So I'm Brandon Phillips. I was CTO and co-founder of CoreOS, which was recently acquired by Red Hat. And the journey that I had with Kubernetes really begins with where we started with CoreOS and our thought process there. So I had started my career at SUSE Linux. And at SUSE, we thought that we were building a product that people just like took off the shelf and built like the perfect infrastructure with. And then reality hit me when I went and tried to build big distributed systems with Linux, just raw Linux at Rackspace. We were building a monitoring system that was hosted, and just all the things that were annoying about deploying software onto Linux, whether it's packaging up the software or what happens when you roll out a version of the software and then you roll back, integrating CI/CD into the whole thing. And so it kind of inspired me and my co-founder Alex to try to figure out how do we fix some of those problems. And so containerization was really what we saw as the thing that would help fix some of these issues around how you roll out and deploy software, so that we wanted to shorten that time from we have an idea of how we want the infrastructure to go, and then you spent like 3 months writing like a bunch of scripts to like do Jenkins and put it up into a S3 bucket and then download it, and then so shorten that time to as short as possible. And so containerization and Kubernetes kind of fell out of that that 5-year journey from starting CoreOS to Docker existing to Google open sourcing Kubernetes, and kind of been involved in the ecosystem ever since.
Okay. And Clayton, you want to introduce yourself?
Sure, I'm Clayton Coleman. It says chief engineer, but I usually say architect or head annoyer. So I like to kind of get things ruffled up and like get people thinking about new ideas. Keep the teams talking to each other, help move along not just the open source community, but the engineering teams at Red Hat, working with our partners. I worked a ton with Brandon even before he joined Red Hat, where we had an extremely I feel like we had a good bond in terms of we always wanted the same things. And we wanted the technology to help people the same way. And so Brandon was always one of the easy people to be like, I know Brandon will agree with almost anything I'm saying. And so now that Brandon has joined Red Hat, I'm arguing with him all the time. So I started at IBM, and I worked on WebSphere and social software at IBM for 10 years. I built large enterprise applications, and I ran those for tens of thousands of users at some of the largest companies in the world. And I left IBM and I went to Red Hat to work on OpenShift, and that was the pre-OpenShift 1.0. Was we want to make it easier to build and deploy software, and to me this was my getting exposed to open source and the ability to just take things and put them together. And we were doing a ton of web direct web-facing running services, a few years after Heroku launched, so this was pretty early in the PaaS for everybody space. And over that journey, I was always a little, I enjoyed OpenShift 1.0 and OpenShift 2.0, but I was always looking for something more. And so when Docker came out, it was very clear that there was something, it's a kind of a gross abstraction, right? I take all this stuff, shove it all together, and then just send it over the internet and do that 100 times a day, like all over the place. But it was one of those ideas that it was just now becoming possible to do that. You could run it on object store in the cloud, and yeah, pulling down a couple 100 megabytes in the cloud is just not a big deal. But the flexibility that it gave you, the ability to just make sure that it was working, and then to go optimize it later, that the flexibility, we had been working on installing things with RPMs onto hosts, and then it wasn't bad, but it was that idea of, it didn't really feel like I was giving control up to someone. And so when we started looking at what we wanted to base the next version of OpenShift around, we talked with a number of people. We worked with the OpenStack community. We looked at Mesos. And I think we got lucky. We had a conversation with Google pretty early on where we had this discussion about, well, we're working on this thing that we're not sure we're going to go out with, but here's what we're going to do. We're like, oh, that's really interesting. But then they didn't call us back. Like, it was kind of an awkward first date. And about 4 or 5 months later, we were starting to kind of get to that point where we're like, okay, we're ready to go to Mesos, just as like it's the best of the options. We talked to some people. And Google called us up and said, hey, we're going to open source this next week. Do you guys want in? And we were like, well, what could possibly go wrong? So when they open sourced it, I got commit access, I think the first day that they open sourced Kubernetes. And it was a great experience for me personally working with some of the really talented people on the project. Brendan, who was talking just a little while ago in the keynote session, Tim Hawken, Brian Grant, Daniel Smith, like a lot of these people who were very fundamental to building these big systems at Google and finding so much in common with, they had things that they hated about the systems they'd built, and they wanted to make it better for everybody. And I had things that I hated about the systems that I'd helped build, and I wanted to make it better for everybody. And I feel like that was a really unique opportunity for me personally, and I've really enjoyed being a part of this because, I feel like we can take some of the lessons that we learned and say, is it the right time, enough people got onto this idea, it was a new technology, a new way of thinking, and we could do things right this time. So I've really enjoyed that part of this journey.
Yeah, I think I just want to touch on that, like the democratizing the way Google's approach and sort of bringing it out to the masses. That used to be one of the sort of CoreOS tenets, right? You want to talk a little bit about how you guys went about that?
Yeah, so when we went through Y Combinator, which is a startup accelerator, and our pitch during demo day 5 years ago, a little over 5 years ago, on stage was Google's infrastructure for everyone. And of course, we made it a hashtag Giphy. And so, Jiffy. And so, for 5 years, even before Kubernetes had come out, that was what our mission was to try to bring this Google-like infrastructure to everyone. And speaking of Kubernetes being introduced, we got lucky in some ways too, because Google, when they built Kubernetes, they selected this this database that we had built called etcd, because we're a startup, and so we do two of the easiest things. We released an operating system and a database in like the first 8 months of the company, and so they chose etcd as the database for Kubernetes, which really made it.
It was a brilliant decision. It's funny. So I'll take a slight digression. It's interesting. So I spent a lot of time in that period where I was looking at new technologies, and I was like, what is it that makes something about this compelling? Like, what's the idea out of this that makes it easy? And etcd is just a key value store. That's it. But it is a reasonably fast, simple, extremely efficient at what it does key value store that runs in a distributed manner. And it's surprising because I've worked with plenty of people at Red Hat who work on things like Galera, and they've used Cassandra at scale and used Postgres master-slave replication. And I've talked with the people on the Red Hat high availability side. And it's not that any of those things don't work. It's that they have evolved and they've built up complexity because there were abstractions that were really missing, or tools that we just didn't have common language to talk about some of these problems before. And I think etcd was actually one of those really compelling it was the seed of an idea that, even though it's not perfect, there's still challenges with it, it's simple enough that it moves the discussion to the next phase like Kubernetes. And I think that was one of the best choices I think they made in the early days of Kubernetes, was just pick something that will be HA, always.
Simply.
Yeah, simple. It just, and people always ask us, should I run 3 etcds or 5 etcds or 7 etcds? We're like, no, just run 3.
Just right.
You'll be fine. And more or less, it's just been that way.
Well, speaking of, sort of running etcd simply, right? One of the next sort of evolutions we took in Kubernetes is towards this operator framework, and one of the first implementations of that was etcd. Can you tell us a little bit about how you arrived at that idea that, this operator approach is, viable and approach we should follow in Kubernetes?
Yeah, so if you're not familiar, operators are these this concept that CoreOS introduced about 2 years ago, where what we want to do is imagine a public cloud, but public clouds don't let you introduce new services. So what's interesting about cloud is that you can make an API call, and then they give you a new copy of a service. So I make an API call, I get a new Postgres database. I make an API call, I get a second Postgres database. So Kubernetes had this custom resource thing that one of the engineers from Google, Brendan Burns, had introduced really early on, but nobody had really gotten a practical application built against it. And so what we had started thinking about were like, well, how do we make Kubernetes more like a public cloud? We wanted to start to introduce higher level services. Kubernetes is great about abstracting compute, network, and storage. The pods get an IP address. The pods let you run a process. The pods are able to persist to disk. Cool, but really we want to move Kubernetes beyond that. It's sort of like saying that the cloud is just about being a VM. Kubernetes is not just about compute, network, and storage. And so we built a few of these things on this custom resource definition where we built a database, etcd operator, we built a monitoring system, Prometheus operator, and we kind of introduced it into the world. And with the idea that if we made it really easy to create new etcd clusters or really easy to make new Prometheus instances because they're just an API call away on Kubernetes, usage would spike. And we like spiking usage when we're at a startup. And so we introduced these things and actually had huge success. The story that I like to tell the most is Ticketmaster is a Tectonic customer, and so they wanted to enable all their teams to deploy application monitoring. So infrastructure monitoring is like what a lot of sysadmins care about. Again, compute, network, and storage is the CPU spiking? Am I saturating the link between the servers? That's fine, but there's also application health monitoring, and that has to be maintained by the application developers. And so we introduced this Prometheus operator. You're able to make an API call via the monitoring system. And Ticketmaster, over the course of like 4 or 5 months of introducing Tectonic into their ecosystem, had like 400 instances of Prometheus across their infrastructure because all of the different application teams were like, all right, well, I want to monitor the health of the application. And it's only an API call, and now I get this full monitoring stack that I can just plug into and configure using Kubernetes API calls. And so it's pretty cool. You go out with a hypothesis, and then you actually see the hypothesis work. And really, it's just like anytime you make something an API call away, usage always spikes. The trick is to make that API call tied to money, but that's another thing.
Well, and I was gonna add to that, like that idea. Kubernetes has the idea of controllers, and the controller patterns. When I worked on web apps, someone would do something on a web page, and we'd update a transaction in the database, and that'd be done. But when you have multiple participating things in a system, you've got to go and make the change in the database. Then you might have to go talk to an external system, and then keep it up to date, and then it might get rolled back, and you deal with all this complexity. One of the interesting ideas in Kubernetes that was a kind of a learned thing from Google internally they hadn't quite pushed it all the way, but it was part of the paper that they put about Kubernetes, and it was something we talked about a lot in the very early days was the benefit of a controller is anything you do all the time fails right away when it doesn't work, which is a really simple idea, but it takes a while to get over that, which is, well, sysadmins in the room would know this one, if you've never restored your backup, you don't have a backup system, you have a very expensive tape drive array. Right, is that if you haven't tried to restore something, restore's not going to work. You don't know that it's going to work. And the same thing applies for controllers. If you have something that goes and mints out 50 pods, well, if there's a bug in it, you find that out pretty quick because it doesn't mint 50 pods, it mints 50,000 pods. And so going through that model of anything that you do all the time, that you keep doing over and over, I think operators really benefit from that because that's actually the big insight is you put an API on it and you tie that to something that's just checking. And it's stupid. It can start stupid and be inefficient and do that checking all the time. But you know what? Computers are pretty cheap right now, and human time is really expensive, right? Everyone in this room who's a developer or a sysadmin, if we had more automation to help us, we could do more things. And I think that's the, make the machines do the stupid repetitive stuff instead of the humans. And that ties into a lot of the learnings with operators in Kubernetes and things that Google talks about, like Google for Everyone, the SRE model is put the things that are important under automation and do them all the time because that's what computers are good at.
So this is kind of like I personally see this sort of controller operator trend being used quite pervasively now for a number of distributed systems. What other trends are you guys seeing that, around open source software and Kubernetes today?
Okay, let's see what trends. So an interesting thing that I think the cloud has made more prevalent is the idea that if things are all services, you have these different types of services that are at different levels of abstraction. One thing that I've kind of struggled with when looking at cloud provider APIs is that if you're producing a service for an audience, whether it's a big audience or a fairly tight-knit audience like big data or some use case, you're going to focus on 80% of the use cases, and you're going to try and get those really well. And that actually helps. You pick a pattern that a lot of people use. Many people can find that common point of documentation and working through the use case. So if you're running Elasticsearch all the time and someone has a managed Elasticsearch service, you get familiar with it. But a flip side of that is that maybe, and Paul alluded to this in his keynote, but maybe 25 years ago, one company would be like the beacon of all of the innovation, even though we were kind of talking about Google like that. That's not even close to the truth, as Google participated in these open source communities. But the idea that there's this huge community of people doing all of these interesting things, and surprisingly, and the Microsoft Word guys, I think, have a quote, which is, 80% of the features, or let's see, 80% of users use 20% of the features, but it's not the same 20%. And I think that applies in cloud. I think it applies in any of these services. Is at the end of the day, we want to make it easier and easier and easier and easier to run services. The operator pattern and the operator approach we kind of is trying to dovetail into that is it has to be easy to run services, because if my use case isn't solved by you and I can't run it at the scale I need it to, or even run it at no scale at all, it's not very useful. So I end up picking something that doesn't quite fit my use case, and that causes trickle-on problems down the road. So getting to the point where you have the really high-scale, super crazy stuff, and then you have all the one-off things that just work and you don't think about them, but they're what keep the business ticking over, or where they keep the mail getting delivered, that sort of feature. Making it really easy to run things at any point on the spectrum, not just serverless on one extreme, microservices in the middle, and monoliths on the end, right? People say microservices are containers, fits really nicely. I really want to see that spectrum. I want to see, if I can have fat serverless containers that talk to other services running via operators and connect them to applications running in the cloud that are using cloud services. We can't break the speed of light. Data gravity is always going to be a big problem where you're going to have your data in one spot and all these things need to talk to it. That's fine. But we want to make it as easy as possible to build and run those applications as close to your data as you need, or as far away as they need to be for security or for isolation. So that flexibility of use case all the way from serverless on down, I think, is something that underpins everything we're trying to do with Kubernetes and OpenShift and Tectonic and the operators, is that flexibility at many different points in the spectrum.
I think one trend that is pretty exciting is, for a long time when people would do, you go through this exercise when you're trying to build an app. So the exercise would be, you'd all draw something on the whiteboard. So you'd have the networking team involved, and then you have the application developers involved, and maybe the folks that were going to build out the rack. And you'd draw this diagram, and you'd all agree on it, and then the teams would disperse. And naturally, like, the networking team would encode something that didn't work, and you fight over the firewall rules, and the compute infrastructure would not be set up right, like the wrong version of software was installed or whatever. And then the application inevitably would need a completely different networking architecture over time. And so I think what's cool that's happening right now is getting so many different parts of the ecosystem with different personas agreeing around the Kubernetes API is really, really cool, because it means that you translate that diagram that you drew directly into API objects into Kubernetes, and then those API objects can be backed. The networking team can worry about making sure that there's a network policy in place that protects the application from the environment and the environment from the application. The application developers are able to mark that up with, say, deployment data about CI/CD and what version and what Git hashes it came from. And the infrastructure team's actually able to see like what is being consumed and what resources are in use, and do I need to start doing capacity planning moving forward for this application. And so having this like one API that everyone can agree upon and actually reflects directly one-to-one, like the box diagram that you drew, is a pretty important trend. Like, I don't think it's been a while since we've had something like that. Not until like we all agreed on like one language, like Java or something, where we all agreed on like one language. Have we really been able to say like any language, any compute infrastructure, whatever, this is an API we can agree upon. And this is, I think it's a unique opportunity moving forward over the next few years. It enables teams to be a lot friendlier with each other.
And you know what this got me thinking of is there's a particular meme that I hate when people say it, like, you're not Google, right? It's a very like, hey, you're over designing this. And sometimes we over design things. That's what we do. We're software engineers. We like building things and seeing what we can make happen. Whenever someone says you're not Google, I like to say, no, you're not. You have far more interesting problems than they do. Because at the heart of it, some of the things that make Google what they are is that they have a ton of software engineers building big, complex systems that layer on top of each other. They have a lot of tools that they use internally. I think those advantages are things that most of the rest of the organizations out there don't have. And so being able to take those ideas, which, even the Google technology isn't that great. You get Tim Hawken up on the stage. I'm not going to speak for Tim, but if you got Tim up on here, like, he'll go on for hours about all the bad decisions they made in previous lives, because we build things, we learn, and we build them better. I really want to see the conversation change, because I talk to people all the time who they build applications, and they build applications that are just as complicated or just as interesting for banks, for retail shops, for line of business inside a company, for IT, that are just as interesting as anything that Google has ever built. And they're under a lot more constraints and challenges. I like to think of what we want to do is make all of the tools available. I don't care if you have 100 one-pod applications, because I bet you those 100 one-pod applications are just as important to you as anything is to any engineer at Google. That part of the problem is give you all the tools so that you can do your job easier. Yeah, you may not need to scale up a Kubernetes cluster to 5,000 nodes or something like that. Some people do, that's fine. But if I have 100 applications and I don't even have to think about them because I was able to simply in an afternoon pull an API together that checks those for health and keeps things ticking off so I can go do something more important, I really, like, that's what, that transition from taking the toil out of developers' lives by giving them these tools that, yeah, they might be like hideously overpowered for the use case you're trying to solve. Doesn't mean you shouldn't use it. I cut down trees in my yard with a chainsaw.
So one of the things you've sort of both been talking about a little bit is the APIs and the abstractions that they imply. And over time, this has evolved. Can you, I guess I'll start with you, Brandon, can you talk a little bit about the type of workloads Kubernetes has, or applications that Kubernetes has supported in the past that recently have been enabled, and where you think that's sort of going in the future?
Yeah, so when we started with using Kubernetes, so we launched Tectonic at Kubernetes 1.0's launch. And how many people have put 1.0 software in production in the room? All right, so you understand the lessons. So a lot of like what we were focused on initially was really just completely stateless scale-out applications for obvious reasons. Nobody's going to be hurt if you lose a copy of a stateless app. And so that was where we started. But over time, we now have more and more these hugely complex applications. You're seeing all the way up to distributed databases going onto Kubernetes. And I think it's just been an evolution from stateless apps to people then feeling confident to put their caches on there, to single node things that like write down to an NFS shared volume, to actually managing large distributed applications. I mean, you're starting to see like Vitess and CockroachDB and a bunch of these other distributed databases kind of having native native Kubernetes operators. So
Yeah, it took us a long time to get the, I remember the stateful set PR, it was called something before stateful set.
Pet
but,
sets.
Pet sets, good lord, I mean, that thing was like 10-page downs of GitHub comments. But any other sort of workloads, anything else you want to add, Clayton?
I think I echo what Brandon says. I'm always surprised by the complexity of the things people are able to build. And it's really, and this kind of is why that you're not Google scale always annoys me. Is Amadeus did some amazing things before 1.0 Kubernetes even came out. And again, it gets down to giving people tools that do one thing and do it well. And Kubernetes gets dinged a lot for being so complex, but I like to think of Kubernetes as just broad. And sure, there's a lot of concepts to learn. You're not forced to learn all of them all at once. That I've seen such complex applications that it's kind of taken me aback. Sometimes they've done really interesting things with front-end load balancers that talk to multiple clusters. Way before anybody in the community actually had anything running as Federation code, people were load balancing applications across the entire world, redeploying applications automatically, and they were doing it with some Bash and some Ruby code and some Python code. They were just gluing these things together, and that flexibility was, I couldn't have predicted what they would have built, but they saw the value in a tool, and they saw how they could take that tool and use it for their own ends.
Right.
And it actually reinforced to me how much more of a job we need to do in the Kubernetes ecosystem of showing people examples of the things that are possible, not just in Kubernetes, but in the general software ecosystem. Examples of what's possible that really help you understand why and how a tool should be used. Like, distributed databases are great if you need a distributed database. How does someone make the choice? And I think that's a trend that we can do a lot better job in Kubernetes. Things like operators and service catalog and documentation and code camps and better education as a whole, which is, here's why this tool is so powerful, here's how you should use it, and there's all these other ways, have at it, but help you orient yourself first.
Yeah. What about Service Broker? You spoke a little bit about ecosystem. I think Service Broker is kind of an interesting thing about sort of enabling a wide variety of services to be easily consumed and sort of having those primitives that people can build on. Anything you want to add there?
The service catalog's been interesting. So for those in the audience, we talked about this last year at Summit, and it's been a part of the Service Broker API was something that was part of Cloud Foundry, and it was the rough idea that if you have a platform that can only run stateless applications, or excels at running stateless applications, then you want to be able to connect those applications stateless. And Heroku did something similar previous to this with its add-on model. The idea of reaching out and just connecting you with credentials has a lot of power. And there's this particular set of audience that, there's different types of applications out there, whether it's big stateful applications or simple microservices or simple serverless applications. I kind of feel like a lot of the early focus on platform really was on we want to make it as easy as possible to get the first step done and then to keep it working and take a lot of that to put a lot of guardrails, safety rails around building an application. This is the pattern that you should follow. And the real world's more nuanced, but it helped people get up to speed. The idea of the Open Service Broker API was just to give you just enough credentials to connect, and that was something that a lot of people in the ecosystem who had these big deployments were using. So it made a lot of sense for us to say, Kubernetes isn't an island. It would be the height of hubris to say that Kubernetes is the best thing to do everything. Like, the real world's much more nuanced than that. You got VM farms, and you're going to talk to cloud services. So it was a great, I think it was the right idea at the right time to say, let's adopt something that the community has brought, that has an active community that solves a particular problem of connecting your applications to these other services, and the details are hidden. And I think as Kubernetes has improved, what we are seeing is we want to make Kubernetes extensible, and it's not Kubernetes, it's just the idea of simple, declarative, composable things that run on flexible infrastructure, and you can just add 30 more of them, and they just keep taking over. You don't have to think about it. The biggest problem with any new piece of software is somebody has to keep it up to date. If you can attack the problem of keeping it up to date and keeping it running, then you open the door to say, well, I can do 10 of those, and then 100 of those, and then 1,000 of those. And so I think over time we'll see that the operator approach kind of fits in the middle. You've got I'm just consuming this. Somebody's got to run those, but maybe those are DBAs or professional service admins or cloud provider. And you've got I build it all myself. That rich middle, I think, is where two teams working together, they don't need a service broker to interact. They can talk to each other over the network. And they've been doing that for years. That's not novel.
So we've got about 10 minutes left before we're gonna leave 5 minutes for questions. So just to sort of switch to some more of the futuristic aspects, right? So I'll ask you this one, Brandon. The next generation of open source software is being designed right now. What do you think its relationship is going to be to Kubernetes and the Kubernetes ecosystem, as well as like the infrastructure that Kubernetes is running on, given that there's quite a shift to public cloud and also the advent of serverless?
Yeah, so I think we are at an inflection point for open source software. For a long time, open source software, you had two options. First is that single machine installs were super easy. You like downloaded an RPM or some bash script and you ran it. Or if it had any component of having to run on more than one machine, it was impossible. Those were the two install methods. You ran through like 1,000.
Don't, or it works.
Right. You ran through like unlimited amounts of documentation. You had to generate like config files that matched exactly or the system wouldn't work, which is pretty unrealistic for how systems have to work today, whether it's load balancers or databases or caches. You inevitably have to have more than one copy in any production setup. And so I think the opportunity with containers and Kubernetes is that these open source systems that always felt too complex to run yourself in an actual realistic production manner, and therefore just kind of defaulted to being, I'll just ask a cloud service. We can actually bring it back to open source, and we can say, well, open source services can be deployed on this open source platform, which is Kubernetes. I think that's a pretty important innovation, because for a long time we struggled. We struggled with, should I deploy it to OpenStack? But then OpenStack doesn't work against the public cloud or my laptop, or really anywhere except for the one OpenStack install inside the business. And so I think that's the interesting thing for open source here in Kubernetes is we have a target now for the open source community, much like we had a target with Linux kernel for the single machine use case.
Yeah, I would echo all of that. I want to see tools that make, and I think this is, you alluded, Steve, earlier to being fast follower, and I think one of the nice things about a fast follower is open source is about people seeing someone else's idea and iterating on it. So a Google paper about Chubby helped inspire etcd. Chubby's Google's internal lock service.
Great name.
Great name, phenomenal. And when people in the community work together, every open source project has some story of someone trying to scratch an itch or to solve a problem, or increasingly today, people trying to build things that empower other people and being generous with the things they've created. So open sourcing the things that help make Twitter successful. And not all of these fit every use case, but if we can go and do just enough to push that a little bit further, we all become better at being fast followers. So I'm always surprised that back to the complexity I've seen. I've talked to people where there's a project launched 6 months ago and they're running something super complex depending on it in production on Kubernetes at an immense scale. And I'm always like, I didn't think that would be possible, but because you understand it, it was able to provide value to you, and you were able to do it. It was the tools building on each other, and I do think we're at that inflection point of open source being reinforcing, and there'll always be services that we consume that other people provide. That's how we get better at doing these things, is somebody else does it better than I can. But there's increasingly an element of, for every person who can do it better, there's 10 or 15 or 20 people that all have that same problem. And they might use the guy providing it as a service, but they might just as well work with a community to make that better on top of open source. And we've seen that, this is what we see all the time in Red Hat, and it's always inspiring to say, we've got a target, we've got that focus. If we can do a better job of helping take some of those services and make them really rock solid in all the different dimensions, everybody else gets to build on top of that, and then everybody benefits.
Yeah, I think another way of thinking about it is, for a long time, open source, we've always kind of gotten in our way. Like, I would argue that Linux package managers never really always got in our way. Like, you're always fighting with this library dependency or whatever. But for the first time also with Kubernetes and with a large thanks to Docker, like, we have the opportunity for open source communities to actually just provide solutions that work correctly, like no matter where you deploy them, whether it's public cloud or on your laptop or in your data center. I mean, in the past, it's always been this huge struggle. You find a Git repo that is like looks interesting, and then you spend the next half a day trying to just get the darn thing to run.
Yeah.
You edited that several times in your mind. I saw you.
Yeah, many times. I forgot we were being recorded. Yeah, so I think that's a big change. And huge thanks to Docker for like thinking of how do we repackage Linux software in a way that you can read a README and it says, oh, here's a thingy, and then you can run the thingy on your laptop, and it works more or less the same no matter where you go. So.
As I've gotten older, I take a perverse pleasure in something that's so ugly that it just works, and it works all the time. And downloading giant blobs of entire file systems from the internet is a terrible idea, and it's amazing that it works every day. So I think early on in Kubernetes, we had a bug where we were always pulling a particular image. And when Docker released their stats for number of images pulled pretty early, it was like 100 billion images pulled, 10 billion of those from this one bug in Kubernetes. We didn't notice. Like it actually got, they were like, hey, you guys are hitting us. And I'm like, oh, we're really sorry. And that's sort of, Bash is one of those things that everybody loves to hate on Bash. Like it's the glue that binds together everything, and it's terrible and it's ugly and it makes us more productive. I want to be that terrible, ugly glue that makes everything more productive.
Yeah. So I'm going to open up to questions, but just to sort of summarize, right? I hope that your takeaway from this is that we have a fairly good understanding of these distributed systems problems, and that we're very motivated to try and make it easy for you to be productive.